Hey guys, in this video I'm going to give you an introduction step by step to the 3D distance formula, which is the result of applying the Pythagorean theorem 2 times. So the first step is know how to construct a coordinate system that is three-dimensional. So how do we do it? Draw 3 lines perpendicular, all to one another. Okay, so what you have is one line that looks like this. This is the z-axis. Draw another line that looks like, let's say, this one here. This we call the x-axis. And then the last one here is the y-axis. There we are. So x, y, and z. This is our 3D coordinate system, and we are going to get a distance formula. Well, how do we do it? We've got to get some triangles in, because we are going to apply the Pythagorean theorem 2 times. It looks like this. Draw a line over here parallel to the x-axis. Okay, I'll draw another line parallel to the, let me extend this one here. There we are. Draw another line parallel to the y-axis. So it looks like this. Once you've done that, connect these 2 points with a straight line. And you have a triangle within the xy plane, which means the following. That the length of the line here, okay, that line, you can find using the Pythagorean theorem. Once you do this, then you extend this into 3 dimensions. Once again, then you will use the Pythagorean theorem, okay? So this segment here, that has a length of y2 minus y1. This segment has a length of x2 minus x1. So this is your x2. This is x1. This is y1, and this is y2. Okay, so y2 minus y1, x2 minus x1. Some people write this in absolute value. Okay, which means by the Pythagorean theorem, then of course, that this one here has a length that is given by x2 minus x1 squared plus y2 minus y1 squared, and then the square root of this is the length of this segment right here. Okay, so let me trace that segment with another color here. Okay, so this quantity is the Pythagorean theorem applied only within the xy coordinate plane to find only the length of this line. Once we have that, then because this is 3-dimensional space, imagine you have a point Z somewhere up above, maybe here. So draw that point to it, you see? So there it is. Then this here would be labeled as, for example, Z2 minus Z1. Okay. Lastly, connect this point with that point, and what comes out, as you can tell, is a triangle. See? And now we find the length of this, which is the distance between the two 3D points, meaning this point here and that point there. Okay, we find it as follows. We know that that length is given by this. We know that this length is z squared minus z1. I'm sorry, z2 minus z1, which means that length is found as, we'll call it d, equals huge square root symbol, and write the following. This quantity here, which is that, square it, so we'll get rid of the square root. So you'll have x2 minus x1 squared plus y2 minus y1 squared, and at the end we have now this new one, which is z2 minus z1. So z2 minus z1 and the whole thing squared. And this is how you find the distance between this point and that point. Okay, this segment here, let me trace that with an orange marker that I am tracing. That segment is given by this. The length of that segment is equal to this quantity here. Okay. And this is nothing but a double application of the Pythagorean theorem. In other words, first you apply the Pythagorean theorem on xy plane to find this. Then you apply the Pythagorean theorem to find that. And the output from the first application of the theorem is this, which becomes like the base of this triangle, you see? Then you feed it into the Pythagorean theorem again, and it gives you this quantity here. Okay. So here what you may want to do is remember, labels these things as, this would be labeled, for example, as x2, y2, z2, and that point would be labeled as, I'm going to draw an arrow to it, would be labeled as x1, y1, z1. Okay? So these are the coordinates of this point, these are the coordinates of that point. Plug into this and it tells you what the distance is between them. In other words, imagine that you are a little dude and you've got to travel up this hill here, okay? And you want to know how long it will be. Well, that is exactly what this thing is telling us. Raise your arms up into the air, you've reached the summit. That's it, right? So from here to there is this quantity, whatever it comes out to be, once you know x1, y1, z1, x2, y2, z2. There you go. So this is the kind of logic behind the three-dimensional distance formula. And this guy gets a medal. He reached the summit. Anyway, thank you for watching and have an absolutely amazing day.